Let's take a look at a couple more examples of graphing cube root and square root graphs. These ones are going to put everything together, so stretching and shrinking and compressing and flipping and shifting and everything combined into one, including a look at the end about a couple things you may want to use your graphing calculator for. So if you haven't watched the other videos, if you're looking for some more basic ways to start, you maybe want to go back and watch those previous two videos. Otherwise, if you're ready for the complicated stuff and the calculator stuff, well, then you've come to the right place. So let's go ahead and actually start with our comparison, the second direction I have up here. So start with that. I'm going to make a detailed description of what's going on here. So I'm going to draw an arrow pointing to all these numbers and explain what's going on. Remember, we talked about putting that in parentheses. So let's start from the A value. That A value in front is going to be our stretch or our compression. Anything bigger than 1 is going to stretch the graph vertically. So this graph is going to be stretched. This cube root graph, which remember is that sort of S-shaped graph, is going to be stretched, so it's going to be lower and taller on both ends. The -1 inside is our H value. That's always our horizontal shift, but remember it lies to us and it does the opposite of what it says. So rather than move it backwards to the left one, it's going to move it to the right one. And then finally, that value at the end outside of the radical is our K value, and that's our vertical shift. It does what it says it's going to do, so that's going to move the graph down 2 spaces. So there's my detailed description as far as the sketch of this goes. I'm going to graph just one point, and that's that center point or starting point. Now it's normally at 0, 0 unless you've shifted it. So in this case we've moved it 1 to the right and down 2. So there's going to be that one point that I want to see where the graph sort of, the S curve kind of changes directions. So knowing the basic shape and knowing that the S curve is going to be way exaggerated in our sketch because we've graphed it 3 times as tall, I'm going to graph something, I don't know, that looks sort of like that, kind of flattening out towards the ends, and those arrows are going to point more sideways than they do up or down. So there's sort of a very rough sketch of this. And then finally, with our domain and range for the cube root graphs, it's really easy, especially if you've watched the other videos or remember from class. Our domain and range for the cube root graphs is always all reals. You can do the cube root of anything you want, positives, negatives, or if you're thinking visually, the domain is sort of where the graph goes left or right, and I can see it goes forever in both directions, left or right. The range is how high or how low the graph goes, and even though it goes up and down slowly, it does go up and down forever. Okay, let's do one more by hand, then we'll switch over and take a look at the graphing calculator stuff. So this time I see I've got a negative value in front. That negative A value is going to have the effect of flipping your graph around, so it's a reflection over the x-axis this time. The 1/2 is going to compress it, so it's not going to be nearly as tall. I can see that I'm dealing with a square root graph, so the basic shape is going to be that hook shape. And then be very careful on this +2. Notice that +2 is not underneath the radical, so it is your K value. It's going to move your graph up or down. In this case, it's going to move the graph up 2 spaces. Okay, so let's go ahead and graph this one. Something unique happens with this one, so be careful on this. Our starting point, that sort of center starting point, vertex, if you want to call it that, is normally at 0, 0, but now I've moved it up 2. We know what the basic shape of a square root graph is. It looks something like that. However, this time we said it's not going to be this because we flipped the graph around. This graph is actually going to be opening downwards this time. So I have a hook sort of on the other end, the lower end, and it's always flipped vertically for what we're doing, not flipped horizontally. So that will also have an interesting effect on the domain and the range. So there we go. So the domain and the range, let's go ahead and label those. Domain is always x and range is always y. If we're thinking visually, the domain is how far side to side the graph goes. Well, it's starting from 0 and getting bigger, going to the right. So I'm going to say x has to be greater than or equal to 0. In our previous video, we took a look at how to tell that, what that was 0 from the equation. Now our range, again, is thinking vertically. So how high or how low does this graph go? Well, the highest point it gets to is 2, so I'll use that number. Again, we talked in a previous video that we see that 2 in the equation as well. This time, though, it's not getting bigger from 2, it's not increasing, and it's actually dropping from that 2. So for the first time ever, we have a range or a domain, anything, where it's actually less than or equal to 2. So be careful on that. If your graph opens downwards in this case, our range is not going to be greater than, our range is actually going to be less than. Okay, so there's a bunch of square root, cube root graphs without even touching the graphing calculator. However, if you want to take a look at how to enter one of these in, and I'll show you some, I guess, cool things to take a look at in your table, we're going to actually go ahead and type this in our graphing calculator and take a look at a couple things real quick.